So this SAT problem says that there's a model that estimates at the end of each year from 2015 to 2020, the number of squirrels in a population was 150% more than the number of squirrels in the population at the end of the prior year. The model estimates that at the end of 2016, we had 180 squirrels in the population. Which of the following equations represents this model, where n is the estimated number of squirrels in the population t years after the end of 2015? So n, the number of squirrels in the population, is going to be dependent on t, the number of years since the end of 2015. I'm going to have a constant coefficient that I'm going to need to determine, and I'm also going to have a base that I'm going to need to reason out. And I actually reasoned out the base first. After a calendar year, so end of 2015 to the end of 2016, I am going to have 100% of the squirrels that were present that prior year plus an additional 150%. So if I take 1.00 plus 1.50, the decimal that represents 100% plus the decimal that represents 150% increase, I'm going to end up with my base being 2.5. And if I think about what would happen at time 0, putting 0 in place of the time, 2.5 to the 0, b to the 0 is going to be 1. So at time 0, at the end of 2015, my population is going to be represented by A. Now I need to reason out what the population would have been at the end of 2015. I know at the end of 2016 the population is 180. I know I'm going to have 100% plus an additional 150% by the end of 2016 compared to what I had at the end of 2015. So the decimal that represents 250% times the population at the end of 2015 has to equal 180. If you solve this equation for A, divide both sides by 2.5, what you end up with is 72 as the population at the end of 2015.